Hello, welcome to this 3.7 Part B video where we're going to do a couple of examples with initial value problems here. So kind of like in class, I'm going to do one here where our right-hand side, our g of t is a linear, so polynomial in nature, and then we are going to do one that is more exponential in nature. Now, I did include we are going to verify on these that we have a solution for y sub p, but I'm only going to do that for the first one here. Again, the idea is that you differentiate and substitute. So we'll just do it the first one and just get a handle on that. So yp prime here is going to be equal to 3, yp double prime equal to 0. So substituting in to verify this is a solution, we should see that 0 minus 3 minus 2 times 3t minus 4. That is our y that we're testing right here. We want to see if that's equal to 5 minus 6t. So it looks like I get negative 3 minus 6t plus 8. I combine my negative 3 plus 8, and it looks like I do, in fact, get 5 minus 6t on the left. And so, again, I won't verify for the second one. That's the main idea behind verifying there. What we want to get into is practicing solving for the homogeneous portion of this, plugging it in for a general solution, and here with our initial value problem, solving for C1, C2. So in order to do that, I'm going to set up my characteristic equation. Here I'm going to have r squared minus r minus 2 is equal to 0. And it looks like for that, I'm going to get two distinct roots, easily factorable here. So r is equal to both -1 and +2, meaning the homogeneous portion of this general solution is going to be, C1. We want to make sure to include those. C1 e to the -t plus C2 e to the 2t, forming my full general solution with the particular portion of the solution then would look like C1 e to the -t plus C2 e to the 2t plus 3t minus 4, tacking on that y sub p at the end. So now I want to get into my particular solution, meaning I want to solve for C1 and C2. You see how sometimes that language can be a little tricky, but hopefully we'll kind of get the hang of this. So I'm going to start with my first value there. Y of 0 is equal to 3. So I get C1 times e to the 0 plus C2 e to the 0. And then it looks like I'm getting plus 3 times 0 minus 4. So that term right there is going to go away. And I'm going to add my 4 to the other side. So it looks like I'm going to get a system here. C1 plus C2 is equal to 7 will function as my first equation in this system where I'm trying to solve for C1 and C2. So not much I can do here except just find y prime. So for y prime, I'm going to have negative C1 e to the -t plus 2 C2 e to the 2t plus 3. And I'm going to go ahead and plug in 11 equals, I'm going to get negative C1 e to the 0 plus 2 C2 e to the 0 plus 3. All right, so a little more simplifying here. I'll subtract that 3 over, and it looks like I'm going to get a negative C1 plus 2 times C2 is equal to 8. So here is equation 1 for my system. Here is equation 2. This is going to be a nice elimination right here. So my positive C1 will cancel with my negative C1. I do like that. All right, using elimination, I get 3C2 is equal to 15, a nice integer C2 of 5. And going back to my first equation over here, C1 plus C2 equals 7. That must mean that my C2 is equal to 2. All right, or I wrote something wrong there. I plugged that in for C1 instead of C2. So let me fix that real quick here. So C1 should probably be equal to 2. How about that? Okay, so my full solution here for y of t is going to be 2e to the negative t plus 5e to the 2t plus 3t minus 4. So my actual full particular solution right there. So, technically, again, up here, this would still be considered a general. And we understand, hopefully, what we mean when we're talking about the full particular solution right here when we've solved for those initial values. Okay, so hopefully that helps for that one. Again, just kind of going through this process is not much different, which is why I said, this extra video with examples would just be helpful for you in doing the homework. But again, nothing really new for your notes here, just more practice. So again, I'm not going to go through the process of verifying this second one. We will just jump in and find the homogeneous portion of this and write our general solution. So starting with my characteristic equation here, r squared plus 3r minus 4 equals 0. Again, I think I could easily factor that, r plus 4 times r minus 1. And so I'm going to get 2 distinct real roots again. You can see where this is going to start to get a little tricky once I move out of these nice 2 distinct real roots. We're going to have to keep in mind that we do have scenarios for the homogeneous where we have repeated roots and complex roots as well. So get excited for those to all be reintroduced. But for now, we're going to say my y of t here, I'm going to take my homogeneous solution. I'm going to add my y sub p particular solution. So for this one, I'm going to go ahead and write C1 e to the negative 4t plus C2 e to the t plus the particular solution I was given of 2/5 t e to the t. And that will form my general solution here. And when I go to take my initial values to plug those in, being aware that here for this particular solution, I have 2/5 t e to the t. So we're going to have to remember a little bit of product rule as well there when we go to find the derivative. So I'm going to just start with my first initial value here of 1 equals C1 e to the 0 plus C2 e to the 0. And then this is nice. I'm going to get 2/5, but since I'm plugging in that 0 for t, that is actually going to cancel this term right here. Now, I do still have the scenario, kind of like the last one, where this is going to have to function as the first equation in my system. And I'll have to probably solve my system of equations here. So let's go ahead and find y prime. Negative 4c1 e to the negative 4t plus c2 e to the t. And then doing a little bit of my product rule here, that is going to give me plus 2/5 e to the t plus 2/5 t e to the t for the second. Now, plugging in that initial value that we have there, 2 equals negative 4 C1 e to the 0 plus C2 e to the 0. I don't get as lucky with one of my terms here. I do still have a 2/5 e to the 0, but then with my second term here multiplying by 0, I do get that term to go away. So let's see. Moving my 2/5 over, I guess I would subtract 2/5 from 10/5 over here, making this 8/5. And it looks like then I have a negative 4C1 plus C2 on this side. So this is where, we get some lovely work with fractions here. But I have my system of equations. C1 plus C2 equals 1. And a negative 4C1 plus C2 is equal to 8/5. Try to make this as easy as possible myself. I don't know how that'll work out, but I'm going to go ahead and subtract equation 2 from equation 1 to get my C2s here to cancel. 5C1 is equal to, I guess, 5/5 minus 8/5. So that would give me a negative 3/5. And I'm going to divide both sides by 5. So rather than making my fraction a little easier, I believe for C1 here, I'm going to get negative 3/25. So super awesome fractions, but, we can work with it. So if that's a negative 3/25, I'm going to have to add C2 to get 1 as my first equation states. So adding that 3/25 over, it looks like my C sub 2 is going to be 28/25. All right, not integers like the last time, but I mean, again, this process is pretty cut and dry. So finding my full-on particular solution here by plugging in C1, C2, I'm going to get negative 3/25 e to the negative 4t plus 28/25 e to the t plus 2/5 t e to the t. All algebraic stuff that we can do. So just keeping in mind our new work here that we have with our non-homogeneous and, just adding in that particular solution. So I hope that was helpful. As always, let me know if you have any further questions.